is the closed interval -1 to 4, and the range is the closed interval -1 to 2. So let f of -1 equal -1, f of 0 equal 0, and f of 4 equal 1. Also, let f have a derivative function f prime that is continuous and has the graph shown in the figure.
So the graph shown in the figure is the f prime. So I want you to write f prime of x really big. So what you're looking at is not the original function. It is a derivative function. So let's write everything about it. Here I have positive, positive, also positive, negative, and negative. And let's write some information on this real quick. So I am looking at the derivative function. So when I'm looking at this, f prime, when it goes from positive to negative, what is happening to the original? There is a relative max. So here's positive to negative. Let's note on here, there is a relative max. Yeah, if it goes from negative to positive, there will be a relative minimum, but that's not the case on this example. So part A, Jack, let's read.
All right, part A. Find all values of x for which f assumes a relative maximum.
So we're looking for f to have a relative maximum. Didn't we already notate that? So what value of x? Equals 2. And the reasoning has to be, there is a relative max on f because f prime is going from positive to negative. That is because f prime changes from positive to negative. If you just say change a sign, you're not going to get full credit for it, because changing sign could start from anywhere. Okay? All right. For part B, Luca, let's read.
Find all values of x for which f assumes its absolute minimum. Justify your answer.
Okay. For this one, do I have any information about the minimum? Right now, we only know something about the maximum. So this one we have to do last. Meaning we'll need to, at some point, graph it. So let's plot what I know so far. So it is given 3 points. -1, -1, 0, 0. Then I have 4, 1. Let's plot them. -1, -1, 0, 0, 4, 1. And something's going to happen in between continuously. So let's move on to part C. Okay, on part C, Eden, let's read.
Find the intervals on which f is concave downward and justify your answer.
Okay, we want to know when it's concave downward. Would you agree that is concave down? Would you also agree that the given information is f prime? So wherever it's going down, it's going to be concave downward. So it is going down right here. Is that the only place it's going down?
No.
It is also going down right here. So we have two intervals. So we have it at -1 to 0, union 1 to 3, and that is because f prime is doing what? It is decreasing. Describe the behavior of the graph. You can't say negative. It is physically decreasing from left to right. Okay, on part D. Let's see. Julia, let's read part D, please.
Find the intervals on which f is increasing.
So f is increasing. So let's see. It's going to increase when f prime is what? Positive. So where let's see where I see them positive. All of that is positive, correct? So is that one interval or two intervals? Two. Why two? That's at 0. 0 is not positive. So there's got to be a breaking point. So we have -1 to 0, union 0 to 2. And that is because, that should be B, C, because f prime is what kind of sign? Positive. You can't say because it's increasing. It is physically a positive sign. All right, Gordon, E.
Give all values of x for which f has a point of inflection. Justify your answer.
Okay, point of inflection. The graph given is our f prime. So let's go to our point of inflection on f. It happens when we have changing concavity. Specifically, it happens when f prime is changing sign, no, not changing sign, changing directions. So looking at this, we're going to go down and up. That's changing directions. We're going up and down. That is also changing directions. Where else? Down and up, changing directions. So what x values are those? I'll give you the first one, 0. 1, and then 3. And that is because, and I'm gonna say it in a way that's gonna be pretty simple, f prime has a relative extrema. When there's like a little low point, high point, those are relative extremas. What if you forget that? Instead, write out it's going from increasing to decreasing or decreasing to increasing. Is that okay? They'll take it. Because you're really in the end defining what a relative extrema is. That is still correct. All right, now time to graph. And I'm gonna analyze everything on the graph here. So let's see. I'm gonna analyze it from here to here. Anywhere is changing directions. So let's write out something. I'm gonna write interval -1 to 0. Right there. And let's write from 0 to 1. And then let's go from 1 to 3. And I'm getting it from here. All the intervals. And 3 to 4. Oh, that's a weird 4, comma. And if it makes more sense for you to write the intervals on the bottom, that's fine, right here. I kind of like this one better, to be honest. So I can kind of physically put in what the graph is doing. So what I write under here, you could write on the right side if you want, but I'm gonna stick it with the bottom here since the graph is directly above. All right, so we know from -1 to 0, it is positive. And if it is positive, is my graph going up or down? Okay, the graph is going up, that is correct. And does it make sense that these 2 points are going up? And then is it concave up or concave down? Concave down. And then for the next piece, from 0 to 1, we have it positive, so graph is going up again. Is that true? It is increasing. And for that piece, is it concave up or concave down? Concave up. And y'all, I'm getting it from here. If it is positive, the graph is increasing. If it is going down, it's concave down. If it's going up, it's concave up. Yes? Okay. So I'm going to completely move that sign away. From 1 to 3, it is decreasing, going down. Concave up or down? Down. From 3 to 4, it is increasing. Concave up or down? Up. And we know at x equals 2, I don't know how high it's going to be or how low, there will be a maximum. That we know for a fact. So watch what I do. It is concave up, not up, down. And concave down to some point, or up, I mean on this part. And we know we have to have a little mountain, has to stop somewhere. Now, how high up, doesn't matter. But I'm gonna stop right here. Because at this point, it's gotta concave up, so I need to go ahead and make the curve in that manner. Ooh. So by looking at this graph, is there a minimum? Would you agree that's my low point? So now I can answer, according to part B. It says, where can we assume the minimum to be at? X equals how many? X equals -1. And my reasoning that I described all on the bottom here will be good enough. Ideally, we should describe it in words, but I think I've done enough. Is everyone good with that? Again, how high up above doesn't matter. You stop wherever you need to, but just enough to finish off when you get to x equals 4. Good?